Determinants area of a triangle. The objective of today's classes, we will learn how to find the area of a triangle using the concept of determinants. Also, we find the equation of the line joining the 2 points using the concept of determinants. So, this is the objective of today's class. In the lower classes, we have studied that the area of a triangle whose vertices are given by x1, y1, x2, y2 and x3, y3 is given by the expression half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay, what is the meaning of this statement? The area of a triangle whose vertices are. So, the area of the triangle whose vertices are given by x1, y1. Okay, so I'm taking x1, y1 as a of x1, comma y1. This is the first vertex. Okay, then the next vertex is x2, y2. It can be taken as b of x2, comma y2. Okay. Then the third vertex is x3, y3. That can be taken as c of x3, comma y3. So here the area of a triangle whose vertices are a of x1, y1, b of x2, y2 and c of x3, y3 is given by the expression. So here we are finding the area of the triangle, say A, B, C. Okay, whose vertices are x1, y1, x2, y2 and x3, y3 is given by half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is the result already we have studied in the lower classes. The above expression, this expression can also be rewritten in the form of a determinant as follows. Half into determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. This can be taken as delta. Okay, so how you are writing this actually, the first vertex is x1, y1. Okay, so write the first vertex as the first row. Then write the second vertex in the second row, x2, y2. Then substitute the third vertex in the third row, x3, y3. Fix the third column as 1, 1, 1. So the above expression is also written in the form of a determinant as follows. Delta is equal to half into determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. Okay. Actually, when you expand this determinant, then you will be getting this result. We can check that. Here I am expanding along the first column. Okay, since I have the elements here x1, x2, x3, x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So I am going to expand this determinant along the first column. Okay. So this is half into x1 into, delete the row and the column having the element x1. So you are getting a 2 by 2 matrix y2 1, y3 1. In the downward arrow, this is y2 minus in the upward arrow you will get y3. Okay, then uh, the next element in the first column is x2. What is the position of x2? This is a11, this is a12, this is a13. So this is a21. In a21 position, we have the element x2. So for this position, we will have minus sign. Am I right? A21 position. A21 position is, how will you write? This is minus 1 whole to the power 2 plus 1. Minus 1 whole to the power 2 plus 1. So this is minus 1 whole to the power. So we have minus sign here, minus x2 into, now delete the row and the column having the element x2. So you will get the matrix y1, 1, y3, 1. So in the downward arrow, this is y1 minus, in the upward arrow, you will be getting y3. So minus y3, okay, plus the next element in the first column is x3. Okay, now delete the row and the column having the element x3. You'll be getting a 2 by 2 matrix y1, 1, y2, 1. Okay, so when you simplify, you'll be getting y1 in the downward arrow minus y2 in the upward arrow. Okay, now check whether these two expressions are same. In the second term, we have plus x2 into y3 minus y1, whereas here we have minus x2 into y1 minus y3. So what I have to do to get this expression, I have to take the minus sign outside from the second term here. So we will be getting half into x1 into y2 minus y3. So when you take the minus sign outside from this, then you will be getting plus x2, right? So plus x2 into, this becomes y3 minus y1, y3 minus y1, okay, plus x3 into y1 minus y2. Okay. So now you check whether these two expressions are same. Yes, these two expressions are same. So instead of remembering this result, we can use the following result. Since we are studying determinants, so we are using this result, right? And this is very easy to remember, whereas this is not easy to remember, right? So instead of using this big expression, we are using the following result as we have studied determinants, the concept of determinants. So this is the concept of determinants. Okay. So using this result, we are going to find the area of the triangle. We are going to find the area of the triangle. Now I move on to the remarks. Okay. Remark 1. Since area is a positive quantity, we always take the absolute value of the determinant. Okay. Area is always a positive quantity. We take the absolute value of the determinant. Yes, we know that area is a positive quantity. So here we are finding the area. We are finding the area. So when we find the area, if you are getting positive value means then there is no problem. That means when you expand the determinant, you will get both positive and negative values. Suppose you are getting a positive quantity means then there is no problem. Suppose you are getting negative value means then you have to take the absolute value of the determinant. What do you mean by absolute value? Absolute value means modulus value. Absolute value means modulus value. So you have to take, suppose you are getting minus 5 means modulus of minus 5. You have to take the absolute value of minus 5 or modulus value of minus 5, which gives the positive value plus 5. Okay, since we know that area is a positive quantity, right? So if you are getting negative value means then there is a problem. In that case, we have to take the absolute value of the determinant or modulus value of the determinant. That is the first remark. Then the second remark is if area is given, okay, If area is given, then use both positive and negative values of the determinant for calculation. So what is the difference between these two remarks? Here area is given, whereas in the first remark we are only finding the area. Okay, so if area is given means then we can use, you are allowed to use both positive and negative values of the determinant for computational purpose. Whereas in the first remark, if you are getting negative value means we are taking the absolute value of the determinant. We will consider only the positive values. But here we are using both positive and negative values of the determinant for computational purpose if the area is given. So this is remark 2. Okay, what is the next remark? Remark 3 is the area of the triangle formed by three collinear points. What do you mean by collinear points? If all the 3 points lying on the same line, three collinear point means, suppose there are 3 points given means, then the 3 points will lie on the same line. Okay, that means three vertices will lie on the same line. For example, suppose the first vertex is a of x1 y1 and the second vertex is b of x2 y2, third vertex is c of x3 y3. Okay, c of x3 y3. See that here all the three vertices, say a, b, c, a of x1 y1, b of x2 y2 and c of x3 y3 are lying on the same straight line. So there is no triangle. We cannot form a triangle with these vertices because these vertices are lying on the same line. So we cannot form a triangle. In this case, the area is 0. The area is 0. So that is the remark 3, the area of the triangle formed by three collinear points. Since these 3 points are lying on the same line, these 3 points are called as collinear points. Okay, so if the points are collinear, then the area of the triangle formed by these three collinear points is 0. So that is remark 3. Okay. Now I move on to the problems. Problem number 1. Find the area of the triangle whose vertices are 3, 8, minus 4, 2 and 5, 1. So here we are going to find the area of the triangle. Okay, say ABC. Okay, whose vertices are A of 3, 8. This is the first vertex. And B of minus 4, 2. This is the second vertex. What is the third vertex given to us? 5, 1. So that can be taken as C of 5, 1. So here all the three vertices are not lying on the same line, right? So we can find the area of the triangle, right? Using the result, delta is equal to half into determinant x1 y1 1, x2 y2 1, x3 y3 1. So this is the area of the triangle formula. We are using this formula to find the area. Okay, so substitute the first vertex. Using this result, we have 1 by 2 into determinant. What is the first vertex? 3, 8. So substitute here 3, 8. Okay. What is the second vertex? Minus 4, 2. So substitute x2 y2 minus 4, 2. What is the last vertex? 5, 1. So x3 y3 is 5, 1. Substitute here. Fix the third column as 1, 1, 1. Okay. So now we have to expand this determinant to get the area. So half into determinant 3, 8, 1 minus 4, 2, 1, 5, 1, 1. I am going to expand this along the first row. Okay, so half into, in A11 position we have the element 3. Okay, so delete the row on the column having the element 3. You will be getting a 2 by 2 matrix 2, 1, 1, 1. In the downward arrow this is 2 minus, in the upward arrow minus 1. For this question, that is in A12 position we have the element 8. So for this question we have minus sign. Okay, so minus 8 into, if you delete the row on the column having the element 8, then you'll be getting minus 4, 1, 5, 1. So in the downward arrow, this is minus 4. In the upward arrow, this is minus 5. Plus 1 into, in 1, 3 portion, we have the element 1. For this portion, we have positive sign. So 1 into, here you'll be getting minus 4 and this is minus 10. Okay, now simplify this. So 3 into 2 minus 1 is 1, minus 8 into minus 4 minus 5 is minus 9, plus 1 into minus 4 minus 10 is minus 14. Okay, so what you are getting is 3 into 1 is 3, minus 8 into minus 9 plus 72, and this gives minus 14. Okay, so this is 75 minus 14. 75 minus 14 is 61. So 61 by 2, we are getting positive value, so there is no problem. So what is the area of the triangle formed by 3 vertices, 3 comma 8 minus 4 comma 2 and 5 comma 1? It is 61 by 2. Is that clear? So this is the required area of the triangle ABC. Now I move on to problem number. Find the equation of the line joining the points A of 1, comma 3 and B of 0, comma 0 using determinants, and find K if B of K, comma 0 is a point such that area of triangle ABD is 3 square units. Okay, so here we have to find the equation of the line joining the 2 points A of 1, comma 3 and B of 0, comma 0 using the concept of determinants. That means what? What result we can use here to find the equation of the line joining the 2 points A and B? We have studied that if 3 points are lying on the same line, or if 3 points are collinear points, if the vertices, 3 vertices are collinear means, then the area is 0. Area of the triangle is 0. That result we have studied in remark 3. So I am going to use that result here. Okay. So I am going to consider a point P of x comma y on the straight line AB. In the problem it is given that the line joining the 2 points are A of 1 comma 3 and B of 0 comma 0. So we are going to find the equation of the line joining the 2 points B of 0, comma 0 and A of 1, comma 3. I am going to consider one more point. One more point on this line AB. What is that point? Any point. Okay, say P of x, comma y. So I am considering any point on the straight line. Now see that all the 3 points, all the 3 vertices A, B, P are lying on the same line. That is A of 1, comma 3, P of x, comma y and B of 0, comma 0 are lying on the same straight line. So what is the area of this triangle? Obviously it is 0. So I am going to use that result here to find the equation of the straight line joining the 2 points A of 1, comma 3 and B of 0, comma 0. I am using this result. Area of triangle ABP is 0. Okay, so 1 by 2 into determinant x1, y1 is the first vertex. Here I am substituting 0, comma 0 as the first vertex. Okay, so this is the first row, 0, 0. Then I am substituting the second vertex in the second row. So x2, y2 is 1, 3. I am substituting the third vertex. What is the third vertex? That is my assumption, x, comma, y. Okay, so this is the third vertex here. I am going to substitute this vertex in the third row. So x, y. Fix the last column elements are 1, 1, 1 equal to 0. We are not going to find this. It is given. Area is given. What is that? 0. So we can put 0 here. Now we have to expand the left hand side determinant. The determinant given in the left hand side. Right? So So which implies half into expand this determinant. Since the first two elements are 0, 0, we no need to bother about these two elements, because when you multiply anything with 0, then you'll be getting 0 only. Okay, so 0 into something is 0, 0 into something is 0. For example, if you consider the first element given in A11 question, then you will be getting the 2 by 2 matrix 3, 1, y1. So in the downward arrow, this is actually 3, minus in the upward arrow, you'll be getting y. But whatever be the value inside the bracket, if you multiply with 0, then you'll be getting 0 only. That's why we no need to consider about this. Okay, similarly, don't bother about the next value also, because this is also 0. Okay, now come to the third position, that is 1 3 position. In 1 3 position we have the element 1. For this position you have positive sign, so if you delete the row and the column having this element 1, then you will be getting 1 3 xy, this determinant. So when you expand this, you will be getting in the downward arrow this is y, minus in the upward arrow this is 3x. So what you are getting is y minus 3x. This equal to 0, right? So which implies y minus 3x equal to 0. Y minus 3x equal to 0, because 1 by 2 cannot be 0. 1 by 2 not equal to 0. This is non-zero. 1 by 2 is 1 by 2 only. That cannot be 0. So what is the possibility here? Y minus 3x is 0. The other possibility is y minus 3x equal to 0. So y minus 3x equal to 0 means then y equal to 3x. So which is the required equation of the straight line AB. So we have got the equation of the straight line joining the 2 points A of 1 comma 3 and B of 0 comma 0. Okay. Also, we have to find the value of k if b of k comma 0 is a point such that the area of the triangle ABD is 3 square units. So D is any other point. It is not lying on the line AB. Here D is a point which is not lying on the line AB. Okay. So if D is a point such that area of the triangle is 3 square units, which means that from this statement it is clear that D is not lying on the straight line AB, correct? Because the area of the triangle ABD is 3 square units, it's not 0. If it is 0 means then D will lie on the same straight line AB. But it is given that here the area of the triangle ABD is 3 square units, right? It is not 0, which means that D is not lying on the straight line AB. Okay, so if this is the condition, if this condition is satisfied, then what is the value of K? This is the next part of the same question. So we are going to find that. Since the area of the triangle ABD is 3 square units, we have half into what is the area formula? X1, Y1, 1, X2, Y2, 1, X3, Y3, 1. X1, Y1 is the second vertex, 0, 0. Here you can use the first vertex as the first row also, right? Then this is the first vertex 1 comma 3, so this is your second row, and the third vertex is D of k comma 0 is a point, right? So k comma 0, substitute here k0. The last column elements are 1 1 1 equal to, here area is given, it is 3 square units. So if the area is given means then we have to use both positive and negative values of the determinant for computational purpose. That is the remark 2, right? So I am considering both positive and negative values of the area. Since area is 3 square units, I am considering plus or minus 3. I am considering plus or minus 3. Okay. Now expand this determinant. Here the first two elements are 0, so don't bother about this. You consider the third element given in 1 3 question. So when you expand this, what you are getting is 1 into, in the downward arrow this is 0, okay, minus in the upward arrow this is minus 3. Already we have 1 by 2 outside. So minus 3k by 2 is equal to plus or minus 3, which implies minus 3k is equal to plus or minus 3 into, therefore minus k is equal to plus or minus 3 into 2 by 3. So you can cancel 3. This is minus k is equal to plus or minus 2, which implies k equal to, okay, bring this minus to the right hand side, then that becomes plus or minus 2. Here we have, okay, so if you multiply this by minus, then it becomes minus, minus into plus, minus, minus into minus, plus. So minus or plus, k equal to minus or plus 2. So we are getting two different values for k, minus 2 and plus 2. Right? Now come to problem number 3. The same type problem, similar type problem as we have discussed in problem 2. Here also we are finding the equation of the straight line joining the 2 points 1, 2 and 3, 6 using the concept of determinants. So that is the question. Find the equation of line joining 1, 2 and 3, 6. So what is the solution? See the solution. We have to use the concept of determinants. So what concept we are using here? If the 3 points are collinear points, then the area of the triangle is 0. That result I am going to use it here. So for that I have to consider a point, say P of x comma y on the line joining the 2 points A of 1 comma 2 and B of 3 comma 6. The first point is taken as A of 1 comma 2 and the second point is taken as B of 3 comma 6. Okay, then the 3 points A, B, P are collinear. Okay, therefore the area of the triangle ABP will be 0. So what is the area formula? Half into determinant x1, y1 first vertex. Second vertex is the second row x2, y2. Third vertex is the third row x3, y3. And the last column elements are 1, 1, 1. This is equal to 0. We can put this is 0. So the first vertex is 1, 2 and the second vertex is 3, 6. Third vertex is x, y. Now expand this determinant along the first row. Okay. So half into, in 1, 1 position we have the element 1. So delete the row and the column having the element 1. You will be getting 6, 1 by 1, 2 by 2 matrix. So in the downward arrow this is 6 minus in the upward arrow minus 1. Next for this position, that is 1, 2 position, we have minus sign. So minus 2 into, if we delete the row on the column having the element 2, then we will be getting 3 minus x. Okay. Then for 1, 3 position, we have positive sign. Here we have the element 1. So 1 into, in the downward arrow, this is 3y minus in the upward arrow minus 6x. So 3y minus 6x equal to 0. Now simplify this. 1 into 6 minus y is 6 minus y. Minus 2 into 3 is minus 6. Minus 2 into minus x is plus 2x. This is plus 1 into 3y minus 6. So we will be getting the same element 3y minus 6x. So we can cancel plus 6 and minus 6. Now 3y minus y is 2y. 6x, actually this is minus 6x. So minus 6x plus 2x is minus 4x equal to 0. So which implies 2y is equal to x, or y equal to 4x by 2, or y equal to 2x. Therefore, the equation of the line joining the 2 points is given by y equal to 2x. Right? Now I move on to the next problem. Problem number 4. Find the equation of the straight line joining the 2 points 3, 1 and 9, 3 using the concept of determinants. So here also we are using the same concept because this is a similar type of the previous two problems, right? So consider any point, say P of x comma y on the straight line joining the 2 points A of 3 1 and B of 9 3. The first point is taken as A of 3 1 and the second point is taken as B of 9 3. Here the 3 points are collinear. A, B, B are collinear, lying on the same line. A of 3 1. Say this is P of x y, and this is B of 9 So these 3 points are collinear means then the area of the triangle is 0. Area is 0, right? So I am going to use this result here to find the equation of the straight line joining the 2 points A of 3 1 and B of 9 3. So substitute everything in the formula. Half into, what is the formula? We have seen determinant x1 y1, that is the first row, then x2 y2, third row is x3 y3. The last column elements are 1 1 1 equal to 0. So by using this, we have half into the first vertex x1 y1 is 3 1, so 3 1. Second vertex x2 y2 is 9 3, so 9 3. And the third vertex is x3 y3, so x y. Okay, the last column values are 1 1 1. Now expand this determinant. So half into, in 1 1 portion we have the element 3, so 3 into, you will be getting the 2 by 2 matrix 3 1 y 1. So in the downward arrow this is 3 minus, in the upward arrow minus y. Then in 1 2 position we have the element 1, for this position we have minus sign, right, for A1 2 position. This is minus 1 whole to the power 1 plus 2. So actually this is minus 1. Okay, so this is minus 1. So minus 1 into, you'll be getting 9 1 x1. So in the downward arrow this is 9, minus in the upward arrow minus x. Plus in 1 3 position we have the element 1. So 1 into, this is 9y minus 3x. Okay, 9y minus 3x equal to 0. So on simplification, what you are getting is half into 3 into 3, 9. So 9 minus 3y. Here it will be getting minus 9. This is minus 9 plus x plus 9y minus 3x equal to 0. So from this, 9 minus 3x minus 9 plus x plus 9y minus 3x equal to 0, because 1 by 2 not equal to 0. Okay, 1 by 2 is 1 by 2 only. It cannot be 0. Okay, so which is possible here? 9 minus 3x minus 9 plus x plus 9y minus 3x is 0. Now cancel plus 9 minus 9. Okay, so actually this is not x, this is y, right? So 9y minus 3y is 6y. Then minus 3x plus 6 is minus 2x. So 6y minus 2x equal to 0, or 6y equal to 2x, or y equal to 2y6 into x or 1 by 3 into x. So which implies 3y is equal to x. 3y equal to x or x minus 3y equal to 0. So this is the equation of the straight line joining the two given points a of 3 comma 1 and b of 9 comma 3. Okay. It is x equal to 3y or x minus 3y is equal to 0. Next, problem number 5. Find the value of k if area of triangle is 4 square units and vertices are k comma 0, 4 comma 0 and 0 comma 2. So here we have to find the value of k. In the area of the triangle is 4 square units. Okay, 4 square units and the vertices are k comma 0, 4 comma 0 and 0 comma 2. We know that the area of the triangle whose vertices are a of x1 by 1, b of x2 by 2 and c of x3 by 2. A of x1 by 1, b of x2 by 2 and c of x3 by 3. Okay. So area of the triangle is the absolute value of the determinant. Suppose when you expand the determinant, you are getting negative value means then we have to consider the absolute value or modulus value of the determinant. Okay. So where delta or determinant is equal to half into determinant x1 y1 1, x2 y2 1, x3 y3 1. This is the first vertex, second vertex, third vertex. This is the formula we have studied to find the area of a triangle, right? So in the problem, it is given that area of the triangle is 4 square units. In the remark, we have studied that if the area is given, then we have to use both positive and negative values of the area for computational purpose. Therefore, delta equal to plus or minus 4. We are taking delta equal to plus or minus 4. We are going to find the area of the triangle whose vertices are given by k comma 0, 4 comma 0 and 0 comma 2. Okay. So using these vertices in the given result, we have half into the first vertex is k comma 0, so k 0. Second vertex is 4 comma 0 and third vertex is 0 comma 2, so 0 2. And the third column elements are 1 1 1. Now expand this determinant. What you are getting, c half into expanding along the first row. So if you delete the row and the column having the element k, then you will be getting a 2 by 2 matrix 0 1 2 1. In the downward arrow this is 0, minus in the upward arrow minus 2. Next for this position we have minus sign, but here we have the element 0. So if you multiply anything with 0, then again you will get 0, right? So don't consider this, no need to bother about this. If you delete the row and the column having the element 0, then you will be getting a 2 by 2 matrix, actually 4 1 0. So when you expand this, you are getting 4 minus 0. But whatever be the value here, when you multiply with 0, you will be getting 0. Then in 1 3 position, we have the element 1. So 1 into, for this position, we have positive sign. In the downward arrow, you are getting 8, minus in the upward arrow, you are getting 0. On simplification, we are getting k into 0 minus 2 is minus 2. This becomes 0 plus 1 into 8 minus 0 is 8. So minus 2k plus 8. Already we have 1 by 2 outside. So when you bring this 1 by 2 inside the bracket, then that becomes minus 2k by 2 plus 8 by 2. So which gives minus k plus 4. Okay, so minus k plus 4 is equal to, the area is plus or minus 4, it is given in the problem, so plus or minus 4. Now I am considering two cases. I have two cases. One is minus k plus 4 is minus 4. This is case 1. And the second case is minus k plus 4 is plus 4. So from this minus k value is minus 4. If this 4 comes to the set, then becomes minus 4. So in that case you will get minus 8. Therefore k equal to 8. And from this we are getting minus k is equal to 4. If you bring this 4 to the other side, that is to the right hand side, it will become 4 minus 4, it is 0. Therefore k value is 0. So we are getting two different values for k. One is 0 and another one is 8. Okay. So we have got the values of k here. I move on to the next problem. The same type problem. Find the value of k if area of the triangle is 4 square units. So in this problem also, the area of the triangle is 4 square units and the vertices are minus 2 comma 0, 0 comma 4 and 0 comma k. We are going to find the value of k using the formula, area formula. What is the area formula? Delta equal to half into determinant x1 y1 1, x2 y2 1, x3 y3 1. This problem area is 4 square units, so I am taking it as plus or minus 4. Delta equal to plus or minus 4. We are going to find the area of the triangle, say ADB, whose vertices are minus 2 comma 0. A of minus 2 comma 0, B of 0 comma 4 and B of 0 comma k. So this is given by the relation half into determinant. The first two elements are minus 2 0 1. This is the first vertex, minus 2 0. The second vertex is 0 comma 4, so 0 4. Third vertex is 0 comma k, so 0 k. And the last column elements are 1 1 1. Now expand this determinant half into, in 1 question we have the element minus 2, so minus 2 into, if we delete the row and the column having the element minus 2, then you will be getting a 2 by 2 matrix 4 1 k 1. In the downward arrow this is 4 minus, in the upward arrow minus k. Okay, next element is 0, so no need to bother about this. Actually what you are getting is minus 0 into, if you delete the row and the column having the element 0, then you will be getting a 2 by 2 matrix 0 1 0 1. So this is 0 minus 0. Plus, in 1 3 position we have the element 1. For this position we have positive sign. So 1 into 0 into k, 0, downward arrow, minus 4 into 0, 0, upward arrow. Okay. So 0 minus 0 is 0, 0 into something is 0. Okay, so the only uh, expression you are getting is minus 2 into 4 minus k. So on simplification, this is half into minus 8 plus 2k. Okay. Now bring this half inside. So minus 8 by 2, which implies plus k by, so k minus 4. But the area is plus or minus 4, it is given in the problem. So k minus 4 equal to plus or minus 4. Equate the determinant value to plus or minus 4. K minus 4 equal to plus or minus 4. So we have two cases. Case 1 is k minus 4 is equal to plus 4. And case 2 is k minus 4 is equal to minus 4. Okay, so which implies k is equal to plus 4. If you bring this minus 4 to the right hand side, then it becomes plus 4. So k equal to 8. and from this k equal to minus 4. We bring this minus 4 to the other side, then it will become plus 4. So what we are getting is 0. So we are getting two different values for k. One is 0 and another one is 8. Okay. So we have got the values of k. See the next problem. This is also a similar type problem. Problem number 7. If area of a triangle is 35 square units. Okay, area of a triangle is 35 square units whose vertices are 2 comma minus 6, 5 comma 4 and k comma 4, then k is, what is the value of k? That is the problem here. Okay. So here the first vertex is taken as a of 2 comma minus 6. The second vertex is taken as b of 5 comma 4. Third vertex is taken as c of k comma 4. So what is the formula? We are finding the area of the triangle ABC. ABC. Okay. So in C we are finding the value of k. K refers the x coordinate and 4 is the y coordinate. So in the third vertex we are going to find the x coordinate. It is unknown. It is given as k. So we are going to find the value of k using the result that area of the triangle is 35 square units. Okay. So this is the triangle formed by three vertices: a of minus 2 comma minus 6, b of 5 comma 4 and c of k comma 4. Okay, so we are going to use the result that half into, what is the formula, determinant x1 y1 1, determinant x2 y2 1, determinant x3 y3, sorry, the formula is half into determinant x1 y1 1. The second row is x2 y2 1 and the third row is x3 y3 1. Okay, so substitute the first vertex 2 minus 6, second vertex 5 comma 4, so 5 4, third vertex is k comma 4. So k 4, fix the last column elements as 1 1 1. Okay. Now expand the determinant, so half into, we are expanding along the first row. In 1 position we have the element 2, so if you delete the row and the column having the element 2, then you will be getting a 2 by 2 matrix 4 1 4 1. In the downward arrow this is 4 minus, in the upward arrow this is 4. Then already we have minus 6 here in 1 2 position. In the formula also you will be getting minus, so it becomes plus. So plus 6 into, if you delete the row and the column having the element minus 6, then you will be getting a 2 by 2 matrix 5 1 k 1. So in the downward arrow this is 5 minus, in the upward arrow minus k. In 1 3 position we have the element 1, for this position we have positive sign, so plus 1 into, in the downward arrow this is 25 into 4 20 minus, this is 4k. Okay, so minus 4k. So half into, what is 4 minus 4? It is 0. So 0 into something is 0. Here you will be getting 6 into 5 30. So 30 minus 6k. This is 1 into 20 minus 4k. So we will be getting the same element 20 minus 4k. Okay. 30 plus 20 is 50 and minus 6k minus 4k is minus 10k. Now bring this 1 by 2 inside the bracket. So 50 by 2 minus 10k by 2. Okay. 50 by 2 is 25. 10k by 2 is 5k. So what you are getting is 25 minus 5k. Okay. So it is given that the area of the triangle is 35 square units in this problem. So we have to take plus or minus 35. We have to take delta equal to plus or minus. Therefore, we have 25 minus 5k is equal to plus or minus 35. From this, we can take 5 outside. So, 5 into 5 minus k is equal to plus or minus 35. Therefore, 5 minus k is equal to plus or minus 35 divided by 5. Okay, so this is plus or minus 7. Okay, so we have two cases. One is 5 minus k equal to plus 7. This is case 1. And case 2 is 5 minus k is minus 7. Okay, so from this minus k is equal to 7 minus 5, it is 2. And from this minus k is equal to minus 7 minus 5 minus 12. Therefore, k equal to 12, and from this k equal to minus 2. So, we are getting two different values for k. One is 12 and another one is minus 2. Right? Actually, from this we are getting k equal to 12. It becomes positive. Since we have minus on both sides, you can cancel minus. And from minus k equal to 2, we get k equal to minus 2. Clear? Now I move on to problem number 8. Show that the points A of A comma B plus C, B of B comma C plus A, and C of C comma A plus B are collinear. So it's a show that type problem. Okay. Here we have to show that the 3 points are given. First vertex is A of A comma B plus C. Third vertex is B of B comma C plus C. Third vertex is C of C comma A plus B. Okay. We have to prove that the 3 vertices are collinear. A of A comma B plus C, B of B comma C plus A, and C of C comma A plus B are collinear. Okay. That means what we have to prove? We have stated that if the 3 points are collinear, then the area of the triangle is 0. So we are going to use that result here. Okay. So what we have to show here, if the area of the triangle is 0 means, then I can say that the 3 points are collinear points. Okay, so using that result, we have half into the first vertex is A comma B plus C. So substitute here A B plus C. Second vertex is B comma C plus A. So B C plus C. Third vertex is C comma A plus B. So substitute here C A plus B. The third column elements are 1 1 1. Okay. Now if we are able to show that the delta value, determinant value is 0 means, then the 3 points are collinear points. Okay. How to show that without expanding determinants, we can use elementary operations to prove this result. Okay. So I am using the elementary operations that here R2 goes to R2 minus R1, which means that I have to subtract the elements of R1 from the elements of R2. This is known as first row, and this is the second row. This is the third row. Okay. So subtract the elements of R1 from R2. So what you are getting is B minus A. Okay. The first element in R2 is B. The first element in R1 is A. So subtract the element A from B. So you are getting B minus A. Similarly, C plus A minus of B plus C. That gives plus C minus C will get cancelled, A minus B. Then 1 minus 1, 0. Similarly, use the row operation that R3 goes to R3 minus R1. Subtract the elements of R1 from R3. Okay. The elements of R1 are A, B plus C1. The elements of R3 are C, A plus B1. So subtract the elements of R1 from R3. Okay, so you'll be getting C minus A. Then here, when you subtract B will get cancelled. You'll be getting A minus C, 0. Why we are using these operations? How to choose these operations? We are simplifying the values of the determinant using the row operations. Okay, so I am going to simplify the elements. If I get more number of zeros, then it will be easy to evaluate the determinant. That's why I am using these operations. Okay. So after using these two operations, you are getting this. Now you check whether there are any common factors here. Yes, there is a common factor in the second row, b minus a minus b. The only difference is minus. So if you take minus outside from this, then you will be getting a minus b. Now I can take the common factor a minus b outside. Then this element becomes, if you take this, it will become minus 1. This is 1. From the third row also we have the common element c minus a minus c. The only difference is minus. So if you take minus from this, then it will become c minus a. Okay, so after taking c minus a, this element becomes 1 and this is minus 1, 0. Okay, now I am going to use the operation that R3 goes to R3 plus R2. R3 goes to R3 plus R2. I am going to add these two rows. Okay, if I add these two rows, what will happen? I will be getting 0 here. Plus 1 minus 1 becomes 0. Minus 1 plus 1 becomes 0. 0 plus 0, 0. So now the elements are getting simplified. So that's why we are using the elementary operations instead of expanding the determinant. Okay, after using the elementary operations, the elements will get simplified. Then we can evaluate the determinant easily. So for that purpose only we are using the elementary operations here. Now if you apply the third operation as R3 goes to R3 plus R2, you are getting 0, 0, 0 in the last row. Here all the elements are 0. So if all the elements are 0 means then the value of determinant is 0 that we have studied earlier. So here value of the determinant is 0. So that's what we have to prove here. So if you are getting 0 means then what is our comment on this? Area of the triangle formed by 3 points A, B, C is 0. That means the 3 points A, B, C are collinear. So if you are able to prove that the area of the triangle is 0 means then the 3 points A, B, C are lying on the same straight line. Which means that the 3 points A, B, C are the collinear points. So that is the thing we have proved it here. Okay, by using the elementary operations. So for what purpose we are using the elementary operations? In order to simplify the elements of the given determinant. So after this, if you evaluate, here we don't need to evaluate because all the elements in the third row are 0. All the elements in the third row are 0. So you no need to expand it. We can write the value of the determinant directly here because you will be getting 0 only. Right? Sometimes you may to evaluate the given determinant in some cases. So in this problem, what we have done, we have proved that the 3 points are collinear. So in order to prove that the 3 points are collinear points, we have to show that area of the triangle is 0. Okay, area of the triangle is 0. So first we have substituted the given vertices in the formula. What is the formula? Area formula 1 by 2 into determinant x1 y1, first vertex. Second vertex is x2 y2, third vertex is x3 y3, and third column elements are 1 1. So in this determinant, in this result, we have substituted all the vertices, but we should not put 0. We have to prove this is equal to 0. So we have substituted all the vertices and we have evaluated the given determinant using the elementary operations. So after using elementary operations, then you are getting 0, 0, 0 in the last row in this problem. So value of the determinant is 3. Okay. So value of the determinant is 0 means then the area is 0, delta is 0. So what we can say, what is our command? Area of the triangle 0 means formed by the three vertices are 0 means then the 3 points are collinear points. Thank you.